So what we have coming up next is credential at large-scale organizations, and we're going to have two amazing speakers joining us. Tobias, Gabriel, developer at SAP. Yeah, you know me. I can't wait for that AI rap battle. I'm sorry. It's been on my mind all day. 12:40 Pacific. Go watch that one. And Nikolas, who's a student SAP developer, and they're going to tell you all about what they've been learning and using, how to make Git and GitHub more effective for people that are learning. So take it away, Tobias and Nikolas.
Hi, and welcome from my side as well. Today, we want to give you a quick overview in the next 20 minutes what we learned from our adventures in credential mitigation at SAP and what things we did there. As this is still a topic in motion for us, we will not go into too much detail about the actual findings, but rather focus on the tools and processes we used for that. With that being said, let me quickly introduce ourselves. My name is Tobias, and I'm a developer at the tools team at SAP, where my main focus is on everything around GitHub, from administrating our internal GitHub servers, over doing Git and GitHub trainings, as well as doing working on cross topics like this one. I'm today joined by Nico, who is a master student in our team and did most of the technical implementation of the scanner, and will also later go into detail about that. We both work for SAP, which is one of the largest enterprise software vendors in the world and has over 30,000 developers. With that many developers, we also have a quite big code base. Currently, we have over 250,000 repositories hosted on our main GitHub server, as well as roughly 5 terabytes of compressed source code. With a push to more inner source, meaning that we would like to open up more of these repositories so that every colleague can see them and reuse code, we wanted to make sure that no credentials by accident get leaked there. It happens, and probably already happened every one of you, myself including, that you by accident commit some file, push it up, and then never come back to clean that up. So you have some password or some credentials leaked there. And while in private repositories, that's not critical, when opening up that to organizations or whole enterprises, we wanted to make sure to reduce the risk there as much as possible. However, with that many repositories, our challenge was now to firstly figure out how big of an issue this is and how many credentials are there actually in our source code. And to focus on that, I'm now handing over to Nico, who will go into details how we implement what things we had to keep in mind there, and what consideration we needed to take from there. Nico, take it away.
Yep, thanks, Tobias. I'm Nikolas. Also welcome everyone from my side. Okay, first, to define what we were actually scanning for, we opted to limit our search to just static patterns that can be easily identified via regular expressions, as this appeared to be sufficient for most types of authentication tokens. For example, all AWS keys always begin with the same leading character sequence. Or take Google Cloud certificates. Those are JSON objects that have some constant fields, so you can easily match against those. Also, and mostly just out of curiosity, we looked for Bitcoin private keys just to see if anyone actually committed those. Scanning for secrets in Git repositories is not actually a new problem. So there already exists a handful of tools out there to do so. And even just Git's log utility already has a built-in parameter to perform regex matching. Then there is a pretty nice tool called Git leaks, which uses a slightly more sophisticated approach to identify secrets than just plain regular expressions by also employing entropy measurements. And now, while both of these tools are great, and we would in fact highly encourage anyone facing a similar problem to give them a try first, they were simply not performant enough at our scale. So instead, we decided to implement our own solution, drawing inspiration from those existing tools, but with a more performance-focused approach. The first challenge we faced in implementing this was how to extract all the repository's content across all branches for the entire commit history, as Git offers multiple ways you can do this. You can use Git log to display the history, and it will show you the patches between each commit. Or alternatively, Git cat file may be used in batch mode to just dump the contents of all blob objects. So essentially a snapshot of each file after any changes and not just the changes that occurred. To evaluate these two options, we compared them against each other on a set of 100 test repositories that we randomly sampled from our entire code base. And as you can see here, the Git cat file-based approach is significantly faster. However, this comes at the cost of producing more output, meaning a substantial amount of additional data to be scanned in the next step. Therefore, whichever of these two options is preferable will highly depend on the regex scanner throughput capabilities. To perform the actual pattern matching, we looked at various regex tools out there. And during some initial research, we quickly discovered that standard grep was just not going to be up to the task, primarily due to its lack of multi-line pattern support. So instead, we looked at PCRE grep as a mostly comparable alternative that does indeed support multi-line mode and also some more complex patterns. With that, we were able to scan all blobs from the 100 test repositories in just over 100 seconds. In this process, we also got some support from Lars from GitHub Professional Services team, and he pointed us towards using Intel's HyperScan library. There's a high-performance regular expression matching library that works by pre-compiling patterns and tuning them to a specific CPU's microarchitecture by using vector instructions and some other magic optimizations. This is also, by the way, what is used for token scanning on github.com. As you can see, this yielded a huge performance boost, bringing down the time to just 17 seconds to scan the blobs of our 100 test repositories. Now, looking back at the two options discussed earlier for how to extract the repository's content, it becomes clear that the scanner throughput is not the limiting factor. Therefore, the option of just outputting all objects, so the Git cat file-based approach, should be preferable because the slightly longer time needed to perform pattern matching on the additional data is more than made up for by the time saved not computing differences between files. And putting this all together, it takes 40 seconds to both extract and scan the contents of all 100 repositories. Another observation we made was that of this time, actually a pretty large chunk was spent on just a very few individually large files, and those were all binary blobs or some otherwise auto-generated files that probably shouldn't have been checked into Git in the first place, but that's a whole nother problem. And more importantly, they didn't contain any secrets, or if they did, those were all just false positives. So we decided we could safely ignore them. And we did that by implementing a filter to skip over any file larger than 1 megabyte. And this allowed us to further cut down the runtime to just 22 seconds. Okay, with all this in place, we decided to run this on our entire code base of over 250,000 repositories. And at first, we considered cloning them to a separate machine to perform the scanning there, like we did for the test repositories. But as you can imagine, that quickly ran into a couple of problems, primarily how to get access to all the repositories, including the private ones. But more importantly, this approach would essentially be equivalent to spamming our own GitHub instance. Also, it would just take too long. Just the copying probably takes longer than the entire scanning. But luckily, we already have a server with a full copy of all repositories, our backup machine. Running on the backup, we have direct access to all repositories, while at the same time not taking away resources on the production GitHub instance. On there, the scan job is run in parallel, on a per repository basis. And the main thread gets the list of repositories to scan and then assigns them to the worker sub-processes in a round-robin fashion. And doing it this way, we already achieved good enough load balancing, so we saw no need to implement any more complicated scheduling techniques. With this setup, running on 128 worker threads, we were able to perform a full scan of the entire 5 terabytes of compressed repository data in just 4 hours. And that left us with a list of findings, each potentially being a leaked secret. Now with this, I'm handing back to Tobias to talk to you about what we did with those findings, how we post-processed them, and also about some of the non-technical observations we made rolling out this tool.
Yeah, thank you very much, Nico, for that. And with the scanner now in place, and we actually run the scanner on a daily basis, we are able to get every day a list of potential secrets which match our given patterns. And probably to no one's surprise, we found quite a few, more than one, and actually so many that we didn't want to manually implement and follow-up process or send around some access or things like that. So we need now to take our findings, our matched patterns, and go into more detail about them, of what they are, if they are indeed valid, and things like that. To show you at one example, what we did is Slack webhooks. They look like this and already contain a secret value at the end, which you can use to post to a specific channel. So you only need this URL and can do a post request, and the message gets sent to your channel without any further information. So this is a credential, and you probably don't want that accessible to everyone. While it is not the end of the world if somebody has that, they can still spam your channel, and you probably don't want. But if you just look at these two, and I can say that one is valid and the other one is invalid, you can't see which one is actually still valid and should probably be mitigated. However, what we could do is we just try to send a message to them, and if we see that it succeeds, we know it's valid, and if we see an error message, we know that it's invalid. And we actually did that and saw that one of these two were still valid and should probably be mitigated, while the other one was already invalid or never valid in the first place and didn't need mitigation. And with this, we saw in our case that the majority of the Slack webhooks we've matched with our scanner previously were indeed active and valid and should be mitigated. The same process of verification can be also applied to other, we call them service credentials, which are for accounts which from a central service, like cloud accounts, GCP accounts, or AWS accounts, or even the Bitcoin keys Nico mentioned earlier. Because Bitcoin keys are in base 58 encoded, and you can match for them, and if you receive a list of strings, you can just try them out if they are valid. And we actually found a single Bitcoin key in our code base. Unfortunately, the corresponding Bitcoin wallet was already empty. After having now this list of verified credentials, the next step would be to start a mitigation process. And to quickly summarize what we have now, we have a scanning process in place, which takes the data from the backup, scans them on a regular basis, and then tries to validate them if they are service credentials against a central service. However, with that many findings and so many development teams, we didn't want to create Excel lists or manually send emails around, but rather opted to implement a full service for that. We called it audit service, which takes in these findings and then notifies the responsible service owners, meaning if we can identify them, cloud account owners, Slack owners, and things like that. Or in case of more generic secrets, like the RSA keys or private keys or even passwords, we opted to notify the responsible repository owner so they can review them and decide if they want to mitigate them. Even with token scanning, GitHub announced earlier today, we think that it can replace some of the parts of the scanner, but and then we can focus more on the specific things like the audit service. And we actually noticed when we started rolling out the audit service to our development teams that we received quite a bit of feedback on what things were good and what things were bad. And so I wanted to give you also now a bit more insight into things we found to be important when considering that. The most important thing we noticed is that you need to try to have as few false positives as possible. Probably already everybody had a security scanner that sends out like 300 messages and 2 of them is valid. And this ends up with development teams ignoring the messages. So the of highest importance to us was to ensure an as high accuracy as possible. One thing to achieve that is trying to verify credentials as soon as you have them, either with checking against a central service if they are for some service, or even in case of RSA keys, checking if they are a valid RSA key and not only matching a pattern. What we also noticed is that a lot of credentials are in dependency folders like vendor for Go or node modules for Node.js, and probably imported from other sources like github.com. And so we opted to exclude them, as if they are valid credentials, they probably should already be mitigated at the source, and we didn't want to include them again to send out. The second thing, if you send out notification to people and our development colleagues, was that the first question we received, and what should we do now? So very important was to include relevant guides directly where the notification is as well. So things like cloud accounts, how to check the audit log and what are suspicious activities to watch out for, how to rotate relevant cloud accounts, as well as where to store credentials. Additionally, what is important is to have somebody as in contact where teams can reach out in case they have either questions or if they noticed abuse of some account, so that this can be escalated and properly handled and doesn't end up in a void. And the last thing we implemented, mainly to track progress ourselves, was an automatic revalidation of all the credentials and potential patterns we matched every day. So we have then every day a list of credentials which we know if they get mitigated or not, and as well take the burden from the responsible development colleagues to manually flag credentials as mitigated or not, and don't bug teams about credentials which are already no longer valid. With that, we can also make sure that if credentials don't get updated or mitigated in time, we can either take a look at them ourselves or escalate it as necessary. And with this in mind, this concludes our presentation. I hope you could take some things away when implementing it yourself or when looking for that. And I think we have another 10 minutes for open questions now.
Thanks, Coax. Thanks. That was fantastic. So I really appreciated that session. We had lots of...
Oh!
There you go. Dana was chatting away to us there. Go ahead, Dana.
Thank you, Nikolas. That was awesome to you. I was just curious, Martin, what was your favorite takeaway of that?
Oh, yeah, no, it was the push to inner source was really good to hear about, with how you do it in real life. We've got a session coming up. Gosh, it's very early in the morning, our time in Europe here. But Denise Cooper's coming on later on today. He's obviously a master of inner source and, talking about how inner source is going to be good for free and open source sustainability. But what was fantastic really was to kind of see, SAP doing inner source for real. And then, other things you have to take care of. So that was amazing. Obviously, doing a bunch of regex scares me, but there we go. What about you, Dana? What was your highlights?
I'm going to tell you, finding that Bitcoin key, I'm just bummed that y'all aren't crypto rich. You should have been crypto rich. You just should have been crypto rich. Everybody's blockchain, and then you actually found the key. How excited did y'all get when you found that? This is my own question. How excited? I would have been ecstatic. I would have been like, something good.
Yeah, actually, when we found that, we found rather many patterns which matched them. So I was surprised how many there were. And when we implemented some further verification to see how many of these are actually valid matches or just false positives. And when starting that and applying that on like the first 100 matches, we saw no positive. I was already bummed. And then at the last point, we still found one. And then I also copy pasted that over to check if there's anything on the wallet. And yeah, but it's probably a good sign that we didn't found one. So at least that.
It is. And I'm joking. And all right. I still wish I would have found that key. All right. We got a question coming in from discussions. Andy Grunwald and BCO, they want to know open source the solution, guys.
Yeah, so currently we don't have concrete plans to open source it, mainly out of the reason that we have a lot of very specific hacks in there, which apply to our specific use case and our internal services. But if you are interested in some of the more details, I think we can write up some of the more generic things. So the core implementation of the scanning is rather straightforward, and I think we can see if we can provide there something, but I'll take a look at that in detail on our V.
Fantastic. We had a question also from Randy R505, and they were saying, are successive scans any faster than the first? The one that you mentioned took 4 hours. Are you doing any checking on changed repos, webhooks, that sort of thing?
Yep, not with webhooks, but we're looking if any files within the repository actually changed. But then so far, if anything changed, then we're still rescanning the entire repository, but only the ones that changed.
Got it. And then we got another question here from K Rubot. They were asking, is it possible to have these scans run before users are able to make pull requests? So is there any way, it's like a pre-commit hook, that sort of thing, to stop them getting into a branch? Or what do you do if they're in the pull request? Are they not in history?
Yeah, so the first thing, and I planned to include that in my presentation, but actually missed that, was that including or scanning for credentials in repositories is only the second step. The first step is that you would like to prevent them getting there at all. So you don't need to trigger a mitigation process, because as soon as credentials are on GitHub, you should probably need to rotate the credentials and not only remove them from the history. With that being said, for example, the Git log utility, or if I remember correct, AWS Labs also has an tooling which you can include as a pre-commit hook to scan for patterns and then decline the push or the commit directly on the development machine. However, the scanning solution we implemented was more focused on performance, and as Nico mentioned earlier, is rather optimized on the scan infrastructure, so not a tool which every developer can run on their own. But yeah.
And that's really interesting. So do you have any, this is a question from me now, not from the audience, sorry. But anyway, I'll get back to you in a minute, folks. So do you have any tooling that you use, for developers to kind of set up their local Git environments and get their email addresses set up properly, get any pre-commit hooks, anything like that set up properly in their local environment?
Yep. So we don't have a fully script to run that, as most people are already rather familiar with Git and how to set it up. But we have a very handy quick start guide which says which email address you should set and how you set it up, so that development colleagues can quickly get ramped on Git. And the great thing about Git is actually that most of the people actually are rather familiar with it already and don't need a long onboarding trail for that. So the internal documentation we have around Git is rather limited, and we built there quite a lot on already the open knowledge which is available publicly. And so that's also a great thing about Git, that everything you can find online and don't have to have some paywalled tools around that. Yeah.
That's fantastic. Yeah. So I helped out. I used to work over at Microsoft a while ago, and I helped out with that when the Windows team were adopting Git. And one of the things that they had was some posters around, the 5 stages of Git as they were coming up to speed instead of the 5 stages of grief. So yeah, it's quite interesting sort of seeing the training that different people need as you migrate them. And it's brilliant that your community were just able to pick up and run. So that's fantastic. Another question here from Jamie Sloan. Have you looked into how you can work closely with serverless applications? Seeing the development communities more and more moving in that direction. Are you looking into serverless much yet?
Generally speaking, or in the context of credentials?
Yeah, generally speaking. Yeah, not really with credentials, because I think in terms of credentials, it's not much different, is it? It's just in the config files and things. It's more in general.
Yeah. So me, myself, not directly. There are parts of SAP which look into that, but I'm not the correct person or the correct team to talk too much detail about that one.
Yeah, no worries. Dana?
So, Goal Lincoln H, want to know, can you detect API secret keys? I could answer this, but I'm going to let y'all answer this one.
Nico, do you want to take that one?
Depends on what kind of API. Like most usually have like a fairly constant pattern kind of that you can match against. So most of them we match with pretty good accuracy.
That's awesome.
I guess it would depend on what API specifically.
Yeah. And Nico, we haven't heard much from you yet. What's it like? You're a student in between that, and you're working at SAP now as well. How have you been finding this? What's the thing you've been learning that you wish they kind of taught you at school?
Yeah, it's really nice. Like mostly how to actually program properly. Like the programming you do at university is usually far less advanced. I also think I probably learned more while working than at university, actually, because just if you have a problem and then you're researching the information for this, you directly know how to apply the new knowledge. So it just sticks better, I think.
I just have such a sweet spot in my heart for students and learners. And you hear it, no matter if you're going to university or you're taking an apprenticeship or an internship, I love our GitHub interns. Getting that real world experience is so awesome and important, and getting to do real cool stuff in real life. I mean, for me, it's like, I don't know, if I think about it, it's been like 20 years since I've had to actually, do some studying in university. I know it's hard to imagine. But just getting the opportunity to do stuff for real and live in that size of an environment. And it is so important. The work that y'all are doing so important. As a VP of engineering, it's one of the things that keeps me up at night. It's like, oh no, did we accidentally put a key into a repo? Because it happens. Like if any developer out there says, "Oh, I've never done that," I'm calling BS on that. Like I've even done it. Like who hasn't done it? I bet Martin's done it a whole bunch too. Okay, maybe I've done it once.
I actually did it last week, Dana. So yeah.
So it happens. It happens. And that's so cool. That's so cool that you're getting to do this. I think this is the future, having this end-to-end automation that secures the world's code. It's just fantastic. Martin, we got any more questions coming in from discussions? I think we have time for one more.
Well, let's just take one more question. So the scanning that you've got, does it only work with GitHub Enterprise Server, or would it work with, GitHub.com enterprise accounts, or even, say, GitHub team account?
Like the actual scanning part that we implemented is not GitHub specific. It just uses just calls to Git. So that can be run on anything, but then some of the metadata extraction part that we're doing to find who the repository owner is and that kind of stuff, that's GitHub Enterprise specific. But with using it on github.com, you would then actually have to first obviously clone them all to a separate machine, because wouldn't have quite the nice performance that we have right now, where we can leverage the fact that we already have a full copy on the backup machine.
Right on. Well, thank you so much again for joining us, Tobias and Nikolas. It was a great and interesting talk, and we are so happy to have you here with us today.
Yeah, thank you too.
Yep, thanks. Bye.